Welcome everybody who's now joining this session, the AI and Journalism series from the Walkley Foundation. My name is Corinne Podger. I'm the Senior Manager here for Programs and Education. We'll give it a couple of minutes for people to join. One of the things that we've done in response to feedback from participants is that you'll be able to chat with each other in the chat box. So obviously, keep your chat courteous and respectful. If there's any discourtesy in the chat box, then I'll just remove the people who are being discourteous, but I'm sure we'll all be fantastic and respectful and learn from each other. So if you have a moment to introduce yourself in the chat box, that would be great. Just let us know where you're joining us from. And if you're interested in asking a particular question during this session, you can post it in the chat box or in the Q&A box. I'll be keeping an eye on both of those. I have such pleasure in introducing our two. Yes, it is being recorded, and you will get a copy of everything. So all patients, it should be online by tomorrow. So I have great pleasure in introducing our two speakers today, our trainer, Josh Nicholas, who's a data journalist with Guardian Australia, and our expert speaker, Jaemark Tordecilla, who's a former news director with GMA in the Philippines and is now doing his Nieman Fellowship at Harvard University looking at AI. They're both doing amazing work on using AI tools to speed up the speed at which we can do processes to uncover information, which I think is really exciting. And so without any further ado, we will hand over, I think. So Josh, if you'd like to get us started. And I will start, I'll turn my mic off and I'll keep an eye on the chat box.
All right, good morning, everybody. So I'll get straight into it. So welcome to the AI and Investigative Journalism workshop. I've basically interpreted this as AI and news gathering because almost all of our work, most of our projects involve some kind of investigative element. As Corinne said, my name is Josh Nicholas. I'm a data journalist at The Guardian. That basically means I use data to tell stories. Sometimes this involves using really lovely, clean data sets that I can download from the ABS or someplace like that. But very often the best stories are found elsewhere. They're found in images, in social media posts, in government reports, in video and audio recordings. These are messier data sets than a lovely spreadsheet, and they're often a lot harder to work with. And that's where, over the last couple of years, we've been using AI tools more and more. They help us work with these messier data sets. So a lot of my job usually involves coding, and I learned how to code so I was already a journalist for about 4 or 5 years when I first learned how to code. So I'm proof that it does work. And if anyone has any questions about learning to code, I have basically unlimited opinions on this subject. So please put them in the comments and we can chat about them later. I also did some machine learning at university. And even though I graduated about 1.5 years ago, like so much of what I learned is basically unrecognizable. This field is moving really, really quickly. And so we're basically all just learning to catch up and stay ahead of what's going on. I learned a huge amount putting this workshop together. I have never done a workshop like this over Zoom. It's been several years since I did one in person. So please bear with me if there's some pauses, if I forget stuff, like, you know, hopefully we can all come together and we can learn a little bit here. So let's get started. So this is a bit of an overview of what we're going to do today. I'm first off going to go through a bit of like a conceptual understanding of what is AI and specifically what do I mean about AI when I'm talking about it in this workshop. Then we're going to go through a bunch of case studies. These are case studies of things we've done at The Guardian. I'm going to try and break them down into 3 parts. What was the problem we were trying to solve? How did we go about trying to solve the problem? And then I've got some demos that I'm going to run and we can show you a little bit of what it looks like. I am doing this on my personal laptop. I'm not using my super duper Guardian computer. So I'm using a MacBook Air. And all of the examples that I'm going to run are going to run on my computer. So chances are you could probably run all of them on your computer too. All of the examples, the code for all the examples will be in the GitHub repo for this workshop. GitHub is basically a platform that coders use to share and collaborate on code. You can go and download them for free. You can go and download the repo for free. All of the examples I'm using also use free models. So you don't have to sign up for anything to run anything that I'm doing today. There are a lot more resources in the handout that Corinne I think will share at the end of the workshop. There's also going to be homework at the end of it. That's one of the, I think, the key features of these workshops is that we have a private LinkedIn group. So we'll share some homework at the end of it. And then if you can do the homework, join the LinkedIn group and we can keep talking. We can give each other feedback. We can keep talking about this. So then there's also a Q&A period. And then I'm really looking forward to what Jaemark's going to show us because he's doing stuff that I don't know how to do. And I'm really interested to learn. So I think that's all I wanted to say then. So let's basically jump into it straight away. So what is AI? This is a complicated thing and I'm not going to give you a definition. If you go onto Wikipedia, there's a bunch of stuff there. But when I'm talking about AI in journalism, I'm talking about machine learning. So this graphic is something that I stole from a book that I'm currently reading called Build a Large Language Model. And it's currently being released chapter by chapter. I think they've only released 3 chapters so far, but so far it's been brilliant. But what this graphic really helped me understand is that there's a lot of terms that are sort of used interchangeably. Things like machine learning, when people mean AI. They use AI when they mean generative AI. They use large language models when they mean something else. What this graphic says to me is that a lot of these terms that we are using are actually related and they're hierarchical. So for instance, in the last workshop, which I really recommend people go back and watch, it's on YouTube if you want to go watch it. It was on using large language models and generative AI for creating text journalism. And according to this understanding, generative AI is a form of machine learning. So machine learning are a group of algorithms, a group of models that teach themselves rules from data. We show them a bunch of data and they can learn from the data. So an example that we're all talking about right now is generative AI. You have these gigantic models being released by Google, by OpenAI, by Facebook. They're ingesting huge amounts of data from the internet. Some news organizations are signing deals with these companies so that they can access their archives. They ingest all of this data and they learn rules from the data to accomplish whatever they're trying to accomplish. But there are other kinds of machine learning algorithms. There are smaller machine learning algorithms that are specifically trained for specific tasks, or maybe a couple of different tasks. And a lot of the examples we're going to use, a lot of examples I'm going to show you, are using these other kinds of algorithms. I will also use Gen AI for a couple of them as well. So what do I mean by learning rules from data? So I've got 2 examples here on this slide. The left example is my left, I think it's your left too, is a spreadsheet. It's actually the latest consumer price index from the ABS. Now, if I was going to ask you to get the latest inflation data from Perth, what would you do? You would open up this spreadsheet, or you would download it from the ABS, you would open up the spreadsheet, and you would try and find the column that says Perth, and then you would maybe go down to the last row. If I was going to write code to do the same thing, it would basically do the same thing, because spreadsheets are great. They've got rows and columns, and very often the names don't change very much from spreadsheet to spreadsheet. So I can just write some code to find a column, to find the date, and I can get the data. But if we look at the example on the right, this is a beautiful dog. It's my grandma's dog. His name is Caesar. So when all of us look at this image, we've all got, or most of us have decades of experience of looking at things, right? When we look at this image, we can see the dog there. We can see the dog is separate from the grass. We can see there's some furniture in the background. We can see there's plants off to the side. That's how we interpret the image. But computers don't see images like that. For the computer, the image is just a string of numbers. If I was going to try and write code to extract Caesar from this image, I'm really going to struggle because I can't open up the image and find a label that says this is the dog, this is the grass, this is the plants. It's just numbers. But this is where machine learning can help us, because we can train an algorithm to recognize dogs in images. We can get a whole bunch of images with dogs in them. We can label where the dogs are in the images, and we can get the algorithm to teach itself, this is the pattern that is associated with a dog. And I'll show you an example of this later. I'll run an algorithm that tries to find Caesar in this image. So this is another example another quick example just to show the same thing. So the Polis Center at LSE in London, they have a great database of journalism and AI, and some of it is investigative journalism and AI. And this is an example that really stood out to me when I was going through this database. I really recommend you look through this database. The link is in the handout if you want to look at it at the end. So BuzzFeed News, RIP, love BuzzFeed News, and they did some great stuff. They were doing a bunch of reporting on spy planes in America. So planes that the government was using to spy on people in the country. They got a huge data set of flight paths, of flights and flight paths. And because they'd already been doing some reporting on this, they could look inside this data set and they could find examples that they knew were spy planes. They were able to identify a bunch of examples in the data set. So what they were able to do with that is they could use these examples to train an algorithm. I think they used a random forest algorithm, but that's beside the point for this. They were able to use these examples that they knew about to train an algorithm to find more examples in the data set, right? So you give the model some examples, you can find more examples. I'll give you another example of this. So last year during the Voice to Parliament referendum, we wanted to investigate political ad spending on the Voice to Parliament. Now, Google, Facebook, a whole bunch of big tech companies, they release political ad databases, but they're very, very messy. It's really hard to find anything in them. So what we did is we basically got a random sample from the database. We manually looked at each of the ads in our random sample, and we said, this is a Voice to Parliament ad. This is not a Voice to Parliament ad. And we did that for all of the examples in our sample. Then we used that to train an algorithm. And we used the algorithm to find more examples in our data set. And then we used those examples to train the algorithm again and again. And it got better and better at doing this. And we were able to find a whole bunch of ads in the database. Now, I want to make a distinction between these two examples. So all of us on this call, we could probably look at an ad in the database and we would be able to understand it. We can say, this ad is about McDonald's. This ad is about this ad is about the Voice to Parliament. This ad isn't. What the machine learning algorithm is doing for us there is it's a force maximizer. We can look at a few examples. We can look at a small subset of it and then use that to analyze the entire data set. What BuzzFeed are doing here is something that is not immediately obvious that we could do. If I was to go through this data set that BuzzFeed had, I don't know that I could look at all of the data in there and go, oh yeah, that's a spy plane. That's not a spy plane. That's a spy plane. Because looking at flight paths is not something I, as an untrained human, can do. But machine learning algorithms are pattern matching algorithms. They can find patterns in the data. They can find patterns which are probably spy planes. They can find patterns that are probably Voice to Parliament ads. They can do stuff, they can maximize stuff we can do, but they can also do stuff we can't do. Okay. So I'm just going to do a bit of a summary of what we've talked about so far. So we're talking about machine learning algorithms. It's a subset of AI. There are other forms of AI, things like symbolic logic. Not going to go into that. Machine learning algorithms are trained on large data sets. So the algorithm that we use to find voice ads, we were taking an existing algorithm, and then we were able to retrain it using a much smaller data set. They're really good for these fuzzy, messy problems when it's hard to write explicit rules. So like, for instance, the BuzzFeed example, when we're trying to look at flight paths, I don't know how to, I don't know how to identify a pattern that is a spy plane. I can't write rules to find a spy plane, but it can probably figure it out itself if we can give it some examples to learn from. So you can access these. There are thousands of these algorithms around. I'll show you more on that later. But there are thousands of these free pre-trained algorithms that are available for free on sites like Hugging Face. A lot of the major tech companies also release algorithms as well. So you can sometimes go onto Google and Facebook and download the algorithms from there. If you can't find an algorithm that's already trained to do something you're trying to do, then you can retrain it or fine tune it to suit your purpose, basically. So when we talk about AI in journalism, we often forget that we're surrounded by this, right? There are machine learning algorithms, there are AI algorithms of all sorts in our everyday life everywhere. One of my favorite examples is email spam filters. I don't know for sure that all of them work this way, but a lot of them work this way. So basically what they do is they get a whole bunch of emails. Some of them are spam, some of them aren't. They feed that to the algorithm. The machine learning algorithm comes up with some rules itself that says, this is what is common about all the spam. And then you can use that algorithm on every single new email and say, is this spam? Is this not? That's essentially what we were doing when we were trying to find voice ads in our database. It's exactly the same problem. Recommendation systems is another one I really love. So when you're looking at your Spotify Discover playlist, or you've just watched a movie on Netflix and you get all the, why don't you try watching these too? That's what they're doing, is they're identifying patterns. People who like this movie also like this movie. You like The Matrix, so you probably like The Muppets. No one is explicitly telling them these things. They're just finding associations between what movies people watch and what movies people like. So there's a bunch of other examples on here, like language translation, audio transcription. These are the same things. These are algorithms that are learning from a whole bunch of data. But I want to skip to the end one here, search engines. So Google BERT is actually a really famous machine learning algorithm. We have used it a bunch at The Guardian. So it's a model that they released in 2018. And I don't know that they're still using it, but for a number of years, they were using this model inside Google search in a number of languages. We used Google BERT. That was the model that we retrained for the voice ad project last year. We downloaded Google BERT, we trained it on all of the voice ads that we had in our sample, and we were able to find more of them. So very often, it's not just that we can learn from what tech companies are doing. They often also release the models themselves, and we can use the very models that they're using.
Josh, I might just jump in for a moment there, because if you Google BERT, first of all, you can find that algorithm, but also the search engine drives you towards Google Gemini, which is interesting. And also that the Google BERT site has been what's called deprecated.
Mm-hmm.
What does deprecated mean? Does that mean it's been superseded by something?
Yeah, it's probably something they're no longer supporting. You can still download it on other websites like Hugging Face. That's actually where I downloaded it from. I didn't even download it from Google directly. So it probably means that they're using something else now. They're no longer updating it.
Okay, no worries. I'm just posting it into the chat box, and I'll add it to the handout for those who are watching this on a recording. Yeah, it's just such an interesting thing. I think the way that you're explaining it, yes, I'm familiar with an email spam filter. So conceptually, hopefully, friends, this is starting to swim into focus. And I'm sure we've all, had that moment where we've clicked on something by accident on YouTube, and then that's all that it shows us. So I now see, for example, ballet. I see a lot of ballet, and I'm personally not that, it's not my thing. Claire has raised a hand. Claire, if you could pop your question into the chat box, that would be fantastic. We might just move on, but don't worry, there'll be plenty of time for questions. So pop all your questions in and we will make sure that we get through as many as we can. Okay, sorry to interrupt.
No worries. Okay, so let's dive into some case studies now. As I said before, I'm going to try and break all of these down into problem, process, and then some demos. But as I said, also, I'm doing this for the first time and there may be some fuzzy bits. So the first example I'm going to give you is from the federal election, the last election that we had. We wanted to track pork barreling in as real near time as we could. So for people who don't know what pork barreling is, it's basically when politicians, when political parties, they try and spend money in particular electorates, usually marginal seats, so they can try and win support in those seats. We wanted to do this basically at scale. We wanted to track all of the candidates from the two major parties across the entire election and look at all the spending promises they were making. And to do that, we were going to look at their social media feeds and their media releases. A lot of them also had blogs. So we wrote scrapers for their blogs. Basically, we had a whole bunch of data here. We had a whole bunch of documents of text. There are a load of components to this project. We use machine learning a bunch of different ways here, but I'm just going to focus on one thing, and that is extraction. So from all of these texts, we needed to get certain information. We needed to get who are the people talking? What locations are they talking about? Are they referring to money? Now, those are all fuzzy things because when you talk about money, you don't always use dollar signs. You may just say, we're going to spend $1 million over there. Also, names are very hard to define. So this comes back to, if I was just going to do this as a normal coding project without artificial intelligence, I would have to come up with some rules to extract names from the text. But that's a very fuzzy thing to do. So for instance, if I wanted to get the name Anthony Albanese out of a Facebook post, I could Control F. We can all do that. We can just Control F and search for Anthony Albanese. But if I don't know what the names are, then I have to think of what is a name. In English, a name is often capitalized, but so are all proper nouns, and so is the first word of a sentence. So if I just try and grab all the capitalized words, I'm going to get a whole bunch of stuff I can't use, basically. This is where machine learning can help, because we can train algorithms to identify names. We can train algorithms to identify locations and money and things like that. So the process. So we scraped a whole bunch of Facebook posts. We've scraped a whole bunch of blogs. I spent ages writing scrapers. I think by the end of the campaign, we had 30,000 Facebook posts. We had a couple of thousand media releases and blog posts. Keep in mind also, we have a relatively small team and we were trying to update this every couple of days. And we were also trying to do other stories. So we didn't want to spend all of our time doing this. So this is an example where we actually used an off-the-shelf model. There are quite a number of models that are trained to do exactly this. We used one from a library called Spacey. Spacey is a very common Python library. If you want to work with text, you probably will have worked with Spacey. Spacey comes with models that are designed to do this. And I'll show you how this works in action now. So this is my text editor. This is where I live most of my time in my workday. I've already downloaded a bunch of models onto my computer. Again, I'm running this on a MacBook Air. So I've also written a little bit of code here to grab the Wikipedia page for Santh Jayasuriya, one of my favorite cricketers. And hopefully none of this will break. Something did break last night, which makes me a bit scared. So I've downloaded the page for Sanat Jayasuriya, and what I'm going to do is basically feed the page to this algorithm. I've already downloaded the algorithm. I'm going to feed the page to the algorithm. The algorithm will label basically all of the text that I feed it. It'll say, this is a person, this is an organization, this is a company, this is money, this is a location. There's a whole bunch of categories it will find. I'm just going to extract from that all of the people. So if I run it now, this might take a couple of seconds. Oh, there we go. It went pretty quickly. So these are all the names that are in that Wikipedia page. Now, actually, this is not doing that bad. When I ran this yesterday, I got quite a lot of stuff that were not names. I got a whole bunch of blank spaces. I got some random symbols like equal signs. One of the things we have to learn from all this is actually these are probabilistic tools. They're right 97% of the time, 99% of the time. But we work in an industry that it's binary. This is right or this is wrong, right? So when we use this in practice, I actually wrote a huge amount of code around this to basically error check. I was error checking like, is this a name that has more than one word? You know, have we already seen this name before? Things like that. And for all of the examples I'm going to show you, when we actually use them in reality, we build in a whole bunch of error checking. So that's one version of this. I'm going to show you another version of this. So we've all heard about generative AI models. I'm going to use a large language model to do roughly the same thing. So I have downloaded a model called Mistral. I think it's by a company called Mistral. And they open source these models. So you can download them and you can have fun. You can have a chatbot on your computer. I tried this a number of ways when I was preparing this for this workshop. I tried just copying and pasting Wikipedia articles into the text field and then saying, give me all the names. And I could not stop it hallucinating. Again, I really recommend people go watch the workshop, the last workshop, because there were actually a lot of good suggestions in there for how to stop it doing stuff like that. The way I ended up partially fixing this, at least, because it's still hallucinating, is what I'm doing is feeding the text that I've got as context to the model. And then I'm going to ask it questions. So please list all the names in the text with a new line for each. When I tried this morning, it didn't work. Let's see if it works. And again, I'm running this on a MacBook Air, so it could take a little while to run. That's another big difference between some of these tools. Spacey is a relatively small model. It runs pretty well on my computer. Mistral is gigantic. The file size is huge. It takes quite a bit of computer power to work. It's taken 20 seconds. It still hasn't done. Oh, there we go. Right. So it's now ripping out a bunch of names. It's doing the same thing that the Spacey model did. It's doing it in a different way. I've actually been surprised at how effective the large language models are at doing this. We had a little project the other day where we were trying to extract stuff from comments, and we were really scratching our heads. Is it worth us training a model to do this? And we ended up using a large language model. I basically wrote a loop that looped through it, and we fed it. Sorry, I didn't write the loop. My colleague wrote the loop and fed every comment individually to the large language model and asked it to extract the thing we wanted. Okay. So I'm also going to show you another version of this. So I've got a page on my website. Please don't go there while I'm still doing the workshop. You can go nuts afterwards. But basically, I've got examples that are embedded in my website of all of these tools. Here I've got an example of text extraction. This is actually using Google BERT in the background. I can paste in text here. I've pasted in some text from the Wikipedia page for Richard Feynman. I already ran it this morning, so it's already found the location and the name in this text. But if you want to try this later, we've got a link to this in the handouts. You can try running this as well. One of the things I like about this is it shows you that we can interact with these models in different ways. I've got an example so far where I've coded it directly. We can use examples where we're using a chatbot. If it's something you're doing repeatedly, if this is, if you're constantly having to rip names out of text, maybe you want to build an interface, because then you could just paste in text and hit submit and you're done. There are a lot of ways that this can go. Okay. So, second case study. So this Who Owns Australia was a project we did not long after I joined The Guardian, about 4 years ago. And basically what we were trying to figure out is who controls all of Australia, who controls all of the landmass. And a huge part of that was we had to figure out who controlled all of these pastoral stations, the gigantic pastoral stations in outback Australia. And to do that, we had to connect a whole bunch of data sets. We had to connect pastoral leases to tenure leases to brand directories. We had to do a whole bunch of things like that. This is a common problem that I face as a data journalist, but it's also a common problem that we all face as journalists. One of the issues with doing that is very often the names don't match. So for instance, if I was in some of these data sets, in one data set, I could be Joshua Nicholas. In another, I could be Josh Nicholas. Last year, I had the same issue, and we were trying to look at childcare centers. And in the ASIC database, the names were slightly different to the childcare database. So we had to do what's called a fuzzy match. We have to match names that are very similar, that are probably the same thing, but they're written slightly differently. Now, the way we did it in this project is called Levenstein distance. I absolutely murdered the pronunciation of that, so that's not how you say it. But basically what it's doing is it's trying to figure out what are the strings, the text that are the most similar. And it takes forever. When we were running this project, I actually walked home from the Guardian office one day holding my laptop open so that my computer would keep running. It takes forever, especially if you have a lot of names, a lot of things that you're trying to match. So this is an example of how we can benefit from a lot of the tools that have been built around AI. So one of the first things to know is that computers don't understand text. When you type text, when you type into a chatbot, when you type into ChatGPT, one of the first things that happens is it turns the text into numbers. This is called embedding. And a really key part of that is that these are not random numbers. So if you type in two words that are quite similar to each other, the numbers will be very similar. And we can use that to our advantage. I'll show you an example of this. So I have downloaded an embedding model here, and I've written a little bit of code. And I've got 3 sentences here. Josh is very tall. Corin is very tall. And Muppets live on Sesame Street. So 2 of those sentences are quite similar to each other. One of them isn't, right? So if I run this model, this is what the text gets turned into. Ignore the first and last numbers here. Those just signify the beginning and the end, so they don't matter. If we look at the numbers in the middle, between these first 2 sentences, the numbers are actually very similar. The numbers in the third sentence are entirely different because I use different words. So if I was going to try and match these sentences together, I could very quickly see the first 2 sentences are quite similar. Now, this was actually a very simple example. That's not what embedding models do. I'll show you what happens when I run an actual embedding model. So then it's a gigantic string of numbers. It's hundreds of numbers long. And that's how we can get little nuances between Josh and Joshua, because the numbers are huge and are slightly different, but words that are close to each other get similar numbers. So I'll show you an example of this in action. So last week, we published a story at The Guardian where we were looking at Centrelink waiting times. The government had released some data on this. And we wanted to analyze this data by socioeconomic status, by regional status. We wanted to make maps. But as is often the case, the way the government released the data the LGA names didn't quite match the names when I downloaded them from the ABS. So I had to do a fuzzy match. And the way we did it is basically, I wrote some code that used an embedding model to turn all of the names into numbers. And then I found the numbers that were very close to each other. And those are the ones that matched. And unlike the map example from before, I think there were 530 LGAs in the project we did last week. And it did it on my super duper Guardian laptop in about 4 or 5 seconds. So I've got a similar example here. I've got 2 lists of names. They're quite similar, but they're not exactly the same. So for instance, JT Sports LLC and JT Sport, they're probably the same, right? But they're not the same. So if I run this through my model, oh, that was very quick. So it's matched JT Sport with JT Sport LLC. It's matched Tom Baseball with Tom Baseball LLC. It's found the words that are very close to each other and matched them. Again, I tried very hard to make an AI, Gen AI version of this. Could not stop it hallucinating. But it is absolutely possible. I just haven't been able to crack it yet. I'm sure Jaemark will have some tips for us, actually. So again, I have an example of this on my website. This is using a slightly different technique, but it's basically the same thing. If you want to try this out later, you can input 2 lists of names. In this case, I've got some amazing West Indian cricketers plus Obama. And when I run this against another list of names that are basically just their last names, this should, yeah, it'll take a couple of seconds. It'll work roughly the same way. And one thing to note here is that Viv Richards and Obama are in this list, but they're not in this list. There is no match for them, so it just dropped them.
Josh, could I ask you a quick question about the tool that you're demonstrating here? Obviously, don't do it now. Wait till afterwards. But if people are using this tool as part of their homework, does it matter if more than one person is using it at the same time? Can they just try it out? It'll be more or less fine.
Yeah, so this is basically running on a free server. So that's the reason why I said, please don't do it now, so that we can use it in the workshop. But no, multiple people can run this at the same time. It'll just get slower the more people that are using it.
Terrific. Thank you. And thanks so much for setting it up for us. It's just a wonderful, I think, chance to try something that's practical. And I will maybe just interject for a moment. Folks who are perhaps coming to this session from a non-coding background, just allow yourself to absorb the information slowly. I think, Josh, you said at the beginning that you came into data journalism initially from a non-coding background and you taught yourself along the way. So just to reassure folks that, you know, just take it easy, go easy on yourself. If it's new information for you, just absorb and it'll all come together. And also, of course, if you practice, then you'll have a chance to go, oh yeah, I see, I get why that does what that does. Yeah. Back to you. Sorry to interrupt.
Yeah, so I would just like to really reiterate that I am coming at this from a particular perspective because these are the tools I use and these are the way I use the tools. But you know, there are versions of this that don't require coding, and generative AI is an example of this. As I said, I have not gotten it to work yet, but it is possible to get Gen AI models to do the exact same thing. Another thing I'll point out on this page is that underneath the code, I've got links to the code for the actual examples on the page. I did not make any of these from scratch. I basically just ripped off a whole bunch of other people. I've linked those other people on the site as well. But that's another advantage of code in this sense, is that I don't have to come up with this from scratch. I can look at examples on the internet. I can keep banging at them until they work for me, and then we can go from there. Yeah. Oh, sorry. One more thing. One of the things I love about this kind of technique is it's very scalable. So you can use this on a word, you can use this on a sentence, you can use this on a document, you can use this in reverse. We had to do this in the pork barreling project earlier, an example where very often politicians will make the same announcement multiple times. Very often a local candidate will say, we're going to build this dam over here, and then a front bencher will come along and say the exact same thing. So one of the things we had to do in that project was figure out what are the promises here that are actually the same promise, and we had to drop all the ones that we didn't want. Also, this works on other medium. So this week I've been playing with some code to do this with images. I basically downloaded a whole bunch of artwork from Van Gogh and Monet and Renoir. And I wrote some very similar code to what I just showed you that was able to take one image, so one Van Gogh image, and find all the other Van Gogh images in my data set. I could use one image of a self-portrait and find other self-portraits in my data set. It's not the same as Google image search, but it's very similar. I'm finding similar things. Unfortunately, like, it's not ready for prime time, so I won't show you that yet, but you know, there are examples on the internet if you want to find them. It's called image retrieval, I believe. Okay, so the last example, finding a needle in a haystack. So this is quite similar to the BuzzFeed example and the voice ad example I said before, but this is using images. So during the last election, we were really interested, who are the politicians who pose the most with dogs, with babies, with, you know, large checks to local organizations. And so we were able to scrape a whole bunch of images that the politicians were releasing, but we wanted a way of automatically going through them and finding examples of dogs, of high-vis vests, of things like that. I'm going to go through this example a bit more granularly, because this is different to the previous examples. For this example, we needed to fine-tune our own machine learning model. So how we did it. So there's a brilliant website called Hugging Face. I cannot talk about this website enough. Huggingface.co. This is what it looks like when you go there. If you look at the top, there are a bunch of different tabs here. Models, datasets, spaces are the ones we're going to be interested in. You can create an account on the site for free. You can pay if you want to. So all of the examples on my website are using free versions, the free service that Hugging Face offers. But for instance, you could pay to make all your examples run faster. If we click on the models tab here, so what we're trying to do is find a whole bunch of dogs, etc., in images. This is called object detection. So we're in the models tab here. If you see there's 548,000 models listed on their database. A whole bunch of these are just going to be fine-tuned versions of other models, so they're not all going to be unique. But if we look down the left-hand side here, there's a whole bunch of categories, and we can find object detection. This is very similar to one of the homework tasks, so pay attention to this. There's a whole bunch of different things these models can do. Question answering, translation, feature extraction. So feature extraction is very similar to extracting names from the text, what we were talking about earlier. Text to speech, audio classification. There's a whole bunch of stuff in here, but we're interested in object detection. So if we go into object detection, we get a whole bunch of models listed here. I believe they're ranked by how popular they've been in the last couple of days or last couple of weeks. I think the one we used in the project was called YOLO V8, but don't quote me on that. Basically, we were able to download a model from this website, and the model we downloaded was already able to do some things. It was already able to identify people, for instance, in an image. I think it was also already able to identify dogs and cats in an image. So we could download something that had already been trained to do what we wanted to do. Then what we had to do was teach it how to find other things that we wanted to find. In this instance, there were some fantastic data sets that had already been created for us. For instance, we wanted to find high-vis vests and hard hats. And there are a bunch of data sets that have already been released for free of people wearing safety gear, because that's actually quite a common thing that people are trying to train algorithms to find, probably for like health and safety stuff. So we were able to take these data sets of safety gear And then we basically scoured the internet for images of people with novelty checks. And then our team, all of us, we basically, we used free software to label all of the images. We would highlight the area in the image. This is the person wearing safety gear. This is a person holding a check. This is a person wearing a helmet. We're able to train the algorithm to identify those things in the images. And then what we got out of the end of it is we were able to run all of these images that the politicians had released and identify Anthony Albanese posing with a dog, Scott Morrison posing with a dog. I'm blanking on that politician's name, posing with a check. There were lots of them. And we were able to find the politicians that were most posing with certain things. So again, I'll try and show you an example of this. So finding needles. So I have downloaded a tiny version of the YOLOV dataset. It was already trained to find dogs, so I didn't have to do anything. I've written a little bit of code here, and I'm going to pass it the image of Caesar that I showed you earlier. So I could not find Caesar before by myself, but I'm going to try and find it with this model. Sorry. He was a really huggable dog. So going to run the picture of Caesar through this model, and it has found Caesar. There's a couple of other examples in this repo. I think I also have my cat in here and my turtle. I don't think the model is good at finding turtles, but it's pretty good at finding cats. And again, I have an example of this on my website. This is slightly different. The way this model works is you have to put in some text. So in this instance, dog, cat, bird, and it tries to find the text that most closely resembles what it thinks is in the image. So in this case, this is my cat. It thinks it's a cat, 99% certainty. If we pass Caesar into this, it thinks it's a dog, 99% certainty. You can upload other images to this if you want to play with this, and you can put different labels in there as well, and it'll try and match the label to the text, the label to the image, rather. Okay, quick summary of everything we just went through. We're talking about machine learning models for AI. Machine learning models learn their own rules from patterns in the data. So like the BuzzFeed example, like the example we just showed with finding politicians. It really helps us when we're working with messy data, with unlabeled data. So things like images, things like government reports, things like that. There are thousands of models available for free on sites like Hugging Face, but also you can download them directly. If you can't find something that can exactly do what you're trying to do, you can fine tune them. Also, again, you can put them into other things. You can put them into software that runs on your computer. You can put them into websites like I did just then. And Gen AI tools can do a lot of these things. The issue is often for me is I'm usually trying to do something 10,000 times, 1,000,000 times. And when you're trying to do that, the larger file sizes, the bigger models, they can often be really inefficient to run. But it depends on what you're trying to do. All right, so homework. I see Corin got very excited. So the homework comes in two different forms. It depends on if you can code or if you can't code yet. So basically, if you can code, the idea is to go into Hugging Face, go into the Models tab. I'll show you this all again in a sec. But basically, go into the Models tab and just explore, see what you can find. What are the things that these models can do? If you click through to the model pages, it'll often have huge descriptions, very lengthy descriptions of this is what we were trying to do, this is what it can do, this is how good it is doing that, stuff like that. If you can't code yet, there's another tab on Hugging Face called Spaces. And that's full of examples like the ones on my website. Those are Hugging Face spaces that I've embedded in my website. And so the idea is, can you find some models that can solve a journalistic purpose for you? Are there things that you can find a model that can help you in some way? How would they help you? Could they do things that you couldn't do before? So these are some of the questions. So quickly, let's go back to Hugging Face. So again, if I go back to the front page, the models tab is up here. You can click on that. You can search through. I mean, there's so many things in here. It's actually ridiculous. There's, and you can also do some things like create images, image generation, text generation. There are models for this on here. And the other one is the Spaces tab up here. So there's a whole bunch of spaces. They feature some of them. You can click through, I don't know what this does. Oh, this is a chatbot basically. And you can play around with these models. They will work in the browser. You don't have to install anything. How homework works. So I think Corin has already invited people to the LinkedIn group. I'm not sure exactly. Please post in the LinkedIn group. If you have any questions, if you've been working on your homework, if you have feedback for other people, please leave that as well. We can all learn together. I think there are also rules in the group, so you should follow those rules. Questions?
Josh, thank you so much. That was amazing. And I mean, one of the reasons I kind of perked up is because I noticed, the reference to spaces. I suppose, I'm not a graphic designer, and so I know that there are, many graphic design sites available that I can put things in and create, flyers and so on. I don't want to mention brand names specifically, but that, of course, has been transformative. And I think, obviously, it's nice if one can build something oneself, code oneself, etc. That being said, I think once you understand the principle of a thing, you then perhaps bring greater literacy if you do then learn to code to the process of building your own. Would that be a fair assessment? Because that's certainly what I've seen when I think about graphic design or using a phone to film and edit rather than perhaps using a desktop-based system. It helps build literacy, and then you go, oh yeah, if I'm working on Premiere or Final Cut, conceptually I've got an idea of what it's trying to do because I've had to go at it on a cheap app.
Yeah, absolutely. Messing with stuff is a great way to learn anything, basically. And as I said, I've learned a huge amount just preparing for this workshop because I was trying to come up with ideas and tools that would work to illustrate what I was talking about. And so I was having to use things I wouldn't normally use. Absolutely, this is a great way of learning anything.
Thank you so much. I might ask you to stop sharing so that Jaemark can start sharing in a moment. And in the meantime, there's a question in the chat. How do you keep track of the capabilities and relative strengths of the widening field of models? Which is a sentence that makes no sense to me, but hopefully it makes sense to you. I assume you share institutional experience and results within The Guardian.
Yeah, it's something we talk about a lot. To be honest, keeping track of the field is incredibly hard. It's very decentralized. I follow a lot of blogs, so I really love RSS feeds, so I can just follow a bajillion blogs that are people experimenting with things, that are people doing things. Also, I mean, I actually do love hanging out on like the Hugging Face Spaces page because you can see people trying things that I wouldn't have thought of. So even the way I'm matching names there, no, I did not come up with this. I was just randomly browsing and someone had done something very similar, and I thought, wait a minute, I could maybe adapt what they've done for what I want to do. That's a lot of what I do.
Fantastic. Thank you so much. That's the only question at the moment. So we can pick up more questions. We are on the call until 12. So what I have great pleasure in doing right now is, just one sec. Are graphic designs templates likely to become, let's pick that one up towards the end, John. So there's a question about graphic design templates and whether they can become voice interactive. So something to think about. So I have tremendous pleasure in introducing Jaemark Tordecilla. The article that's on the site, on the share at the moment, is one that popped up in my LinkedIn. I'm very interested in tools that are available to journalists who perhaps don't work at well-resourced or large newsrooms. Quite a lot of the work I've done in recent years has been with journalists in developing country contexts. And so I was just super interested in this. I created an AI tool to help investigative journalists find stories in audit reports And a link to this article, Jaemark, is in the handout, because you do actually step people step by step how you did it. But over to you. Thank you so much for joining us. And I know you wanted to share some thoughts and some tips and links as well.
Right. So I came into my fellowship. I'm currently a fellow at Harvard University with the Nieman Foundation. And I came into the fellowship trying to find a solution for this particular problem. So for the longest time, journalists in the Philippines have been using audit reports from government to try to find leads about evidence of corruption in government agencies. But the documents are really dense, and here's an example of one document for the health ministry, and so it's really like a long assignment for one reporter, and I was trying to find models that would process this document and to basically make things easier for investigative reporters back home. And I was looking at the methods that Josh was discussing, perhaps doing machine learning and training on these sorts of documents. But a year ago, the solutions that were available out there involved massive hours of training just to get through uh, one result for one document. But that all changed with the advent last November of a new feature introduced by ChatGPT, allowing people to do custom GPTs. I'd like to take you through what custom GPTs do. But let's start first with the vanilla paid version of ChatGPT. So it does allow you to process documents, and it would give you, for example, it would allow you to uh, get a summary of a particular audit document. So let's try that. So I uploaded the audit document from the health ministry, and let's see what it comes up with. All right. So it's going to give a summary, but it actually describes the document. It describes it in a way that you would expect a computer to do it. So it just takes the headings, and it really doesn't give you any insight about what the document contains. You can also try asking it, tell it, I'm an investigative reporter. What should I look at in this document? So I've been trying these things, and it mentions some things, but it's not specific enough. It's not going to like give me specific leads that I could then pursue and write a story. It will tell me that there are non-compliance items. It will tell me about low accomplishments, but there's not anything specific. I mean, there's no wrong answer here, but there's nothing specific for me to latch onto and turn into a story. So at this point, I'm still grappling with the prompts, and at a certain point, you're grappling with prompts. You might be better off just reading the document yourself instead of trying to use ChatGPT to find a story in this document. So what custom GPTs do is that it allows you to have a set of instructions to narrow down what you're looking for in the document. So this took me about 16 hours to play around with, but that's including testing how custom GPTs work. And I found this set of instructions to work best for me. It took me 16 hours, but if I were to do it for another set of documents, maybe it's gonna take me 2 to 4 hours. And what I told it to do is just to focus on the significant audit observations. I told it not to summarize the report yet because of technical things that involve tokens in ChatGPT, but I wanted it to just give the user a bullet point summary of the significant audit observations followed by its observation number. And after that, I asked it to prompt the user for more options. So taking that document, I don't even have to write any prompt, and I just feed it, and I hope it works. Okay, so it did what I told it to do, to ask the user, and then just say yes. All right, and it's going to give you specifics about the audit observations in that document. Now, it's interesting because it might look the same, but to a trained reporter who's been covering this beat, some of these things would be immediately familiar. For example, observation 2 is about denied hospital claims by the state insurance agency that has been a big issue resulting in net lost income for hospitals. And then I could chat with it and ask it to tell me more about observation 2. And then it would give me a summary of everything that's in the document about observation number 2 about the claims. I could even ask it to tell me more details about it. Right, so it gives the specific recommendations about that one particular issue. And so if you're an experienced reporter at this point, you know enough to be able to judge whether there's a story in this document or not. So what I really wanted for this tool is to be a monitoring tool, a screening tool that would allow reporters to, instead of investing time and then finding out later on that one document is not worth diving into, this would be like an early monitoring device that at this point they can go into the full document and try to find everything that's inside there that's worth doing a story on. I can even chat with it and ask it to tell me about another observation. Right. What I found interesting is that I did a workshop for reporters who cover this beat, investigative reporters from the Philippines, and without any guidance from me, they were more familiar with the structure of the audit reports, so they knew that some of the documents had notes and additional information. So what they did was they feed additional documents based off the leads that they found in the bullet points here. And so it came naturally for them to augment their skills as investigative reporters. But the key thing about this tool I found is that you can't outsource your critical thinking to the AI. So the AI is really good at summarizing dense documents. In one workshop, one editor remarked that it cut through all the jargon from the reports and put it in good plain English, put it in a very readable format. And so it's really a big time saver for reporters doing this. Now, I did this as a proof of concept because it would be immediately useful for reporters back home. But this is trying to find one type of needle from one type of haystack. So a certain type of information for a certain class of documents. But it's going to take you 2 to 4 hours once you get the hang of it to apply it to a document that your newsroom processes, like legal documents, for example, environmental reports, audit reports, corporate documents. What I found is that really being specific and putting in the guardrails to try to be as specific as possible and not depending on the AI to do thinking for you and just using it for summarization is the best use for this. Just to show everyone how easy it is to create custom bots, I created a custom chat bot for the Harvard Student Handbook. So I just uploaded a PDF of the Harvard College Student Handbook. And the only instructions I did was that you will only use the information in the handbook. You will not use any of your prior training data. And so even with just those 2 sentences, I have a working system that would allow me to answer these questions. All right. So in this case, this is sort of control F. So it's not really a good use of the tool. But you can, what I found it could be really useful in is that if you have imprecise questions, the AI really does a good job. So going back to the needle and the haystack analogy, you just have to describe the needle and you get within the, you know, a general description of the needle, and the AI does a really good job of 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 finding it inside the haystack. For example, I could ask it, my roommate keeps recruiting me for Bible study. What can I do? And let's see what it answers. All right. What's interesting in this answer is that there's no particular language in the document about Bible studies, but there was particular language about religious recruitment. And so the AI was able to connect a Bible study to religious recruitment, and this was the prescription to call the Harvard chaplain's office. Another example, I could ask it. There was a researcher at Harvard who left Harvard. She's a great disinformation researcher named Joan Donovan. So she left Harvard last year and went to Boston University. So I can ask it if I can take Donovan's course at Boston University for credit. That's very specific. I don't think it's going to be in the handbook, right? Yeah, so it's able to give me steps about how I could take a class at Boston University. Last one. If I tell it I'm Muslim and my exam falls on a Muslim holiday, and ask it what I can do, let's see if it figures out an answer. Right. Again, there's no language in the handbook being specific to this particular holiday, but it was able to connect the fact that it was a religious out of sequence exam. And so it was able to give me the correct information in the handbook about religious reasons for missing exams. And so you can imagine that you can take it for any corpus of data that you want and just play around with the instructions. In this case, we limit the hallucinations because I told it just to get the information only from the knowledge sources. And it was able to be a useful tool, which took about 10 minutes to do. The last thing I wanted to share, and because Josh talked about this too, is that it's really good for those trying to learn how to code and trying how to work with data. Um, this spreadsheet, this is just a dummy survey I did for one of my recent workshops, and I could feed this spreadsheet, the survey, to ChatGPT, and it's really great about describing data in spreadsheets.
Just while you're doing that, Jaemark, it's saying up the top there, ChatGPT 4. So this is
Yep.
the paid version of ChatGPT, is that
Yes,
correct?
this is the paid version of ChatGPT.
Mhm.
It costs about $20 a month.
Useful to
But
know.
it allows you to do custom GPTs in that paid version.
Excellent, thank you.
So you're able to use custom GPTs to develop custom GPTs, but for users to use it, they also need to be able to have the paid version of ChatGPT because it's based on GPT-4. And so this is a description uh, of of the fields in that Excel sheet, in that spreadsheet, um, which tells us basically what it contains, and so we can ask things like what is the mean and median age of the respondents. All right. So it gave this mean age and the median age. And what's interesting, if you click on view analysis here, it actually gives you the Python code it used to generate that code. So uh, you can like use it uh, for creating a piece of code that you can then take into your own Python notebook to work for with a bigger piece of data. So it's really a good copilot for coding, but it doesn't just stop at coding. You can actually do data visualizations on it, like um, generate distribution graph of education attainment, the respondents. So while it generates, maybe we could like, answer some questions.
That sounds great, Jaemark. And I think my first question is, this tool that you're demonstrating on the screen at the moment, is this the Beat Assistant that you've developed? And if not, are you able to provide the link to this tool so that people can
Right.
try it out if they
So
have
so this particular tool is just the Chat GPT-4.
it's just
So
the
it's
window.
just the plain not customized at all.
Fantastic.
Um,
That's
Right. So without any work, it's able to generate that graphic. And again, you're able to see the Python code that was used to plot that. It can even do more complicated plots, like can generate a distribution
We might go to the
age.
questions after you've done this
All right.
distribution demonstration, Jaemark, because there are some really great ones in the chat now.
All right, sure. I'll just type in the question, and then when it generates, you can and
This is endlessly interesting, I have to say. I'm fascinated. And Josh, I saw you, is it fair to say, chuckling with delight that you were able to see the underlying Python code?
Yeah, I was actually just I was loving that it's using Matplotlib and Seaborn, which are two very common libraries we use for
right.
visualization, and like they're basically famous for being incredibly finicky. And I love how like simply he was able to do that.
Right. So here I was able to plot an age versus AI use distribution among the respondents, and this is the Python code. You can actually even ask it to generate that same language. And then if you're familiar with R, you can take this code and paste it into R Studio, and you're halfway there basically. So it's really great for productivity if you're working with a lot of data. So yeah, Corinne, maybe we have some questions.
We certainly do. Would you like to stop the sharing? Is that okay? And then we'll be able to just
All right.
see
Oh, sure.
everyone's beautiful faces.
Um, Stop
Wonderful,
share.
thank you.
All right.
Okay, so I think we have some questions from folks. I'm guessing most of us are not coders. And so when you're answering, just keep those in mind. So the first question, going back through the chat box, is I think it's really a question to both you, but perhaps Josh, you mostly, is how do these tools, the tools that you were demonstrating, go or perform on social media? For example, scraping comments lists, and specifically looking for people who are close to a story or who might have good leads. For example, this happened to me too, or maybe Xanthia, another way of saying that would be I hear you, or phrases that people go, yes, I can relate to the experience that you've had.
Okay, so with social media scraping, that's becoming increasingly hard as like APIs have been shut down. Like it used to be very simple to grab data out of Twitter, and it's gotten very hard and very expensive. So these tools won't necessarily help you, or the tools I was showing won't necessarily help you with that because they aren't great at accessing APIs. You often have to get that data and then run them through the tools. But one of the examples I showed was using Facebook data. We used an API to grab a whole bunch of Facebook posts made by politicians, and then we were running them through our models. So I don't know how exactly to answer the second part of the question, but we were able to run social media data through the models. Yeah, I'm not quite sure how to answer the second part though. I don't know how we would do that closeness analysis.
Yeah. So coming up with a way of can one at least get a downloadable format of comments on a series of Facebook posts and analyze those?
Yeah, it depends on what
Short of
Facebook
copy
allows you to do.
pasting, obviously.
Yeah, it really depends on what they allow you to do. Like they've locked down a lot of their APIs a lot, so I don't know if they allow you to access comments anymore.
But let's say, and I'm just teasing this out because I think comments are obviously text. One could copy paste the text into a spreadsheet or into a document and then use that for the analysis, perhaps.
Yeah, exactly. You absolutely can do that. And very often what we end up doing, not with social media so much, but with like government data, for instance, for some reason, they very often put them as like tables on their website or have a whole bunch of text on their website. And very often what I end up doing is just copying and pasting the HTML from the page. So you can, if you right click on any page, you can go view source. You can often copy almost the entire thing. And then, yeah, you can run everything on your website, on your local computer using the HTML from the website. You can grab whatever you want.
This is a really good moment for me to resurface how valuable it will be to this learning community to join the closed LinkedIn group, because there are some really interesting comments being shared in the chat that would be great to, once the Zoom ends, of course, those comments are lost, but we've got a note here to say I found a plugin that could scrape TikTok comments, for example. That's a useful piece of information for everybody. I'm scrolling back up because I want to do them in turn because that seems fair. There's also just a jargon question, which is when we say custom, what do we mean by custom?
Right. So the paid version of ChatGPT allows you to build custom GPT apps. So it will allow you to put in your own instructions to basically build guardrails of what you wanted to do. You can give it a document that would serve as its knowledge base. So if you have a paid version of ChatGPT now. I suggest you play around with it.
Josh, did you want to add to that?
I don't think I can add very much. I haven't really played around with ChatGPT that much, unfortunately.
Okay. There's a question, can we also use tools like these? So I'll just generalize it to analyze other formats. So we've looked at PDFs, we've looked at websites, such as Excel. I think, Jaemark, you've just shown an Excel. So let's talk about CSV or XLX.
Yes, so CSV files are perfect for ChatGPT in terms of processing data. Yeah.
Wonderful, thank you. There's a question from the Q&A box, which is perhaps a more abstract question. Can AI or the tools that we've looked at or tools that are available make an evaluation of decision analysis of organisations, for example, how they arrive at policies?
I think my big takeaway from what I showed is that you really can't use it to substitute for critical thinking. I've seen people like use it to try to find arguments against um, things that they've been trying to do, but AI really shines, at least the generative vanilla ChatGPT 4 shines when you're using it to generate an answer where there are no wrong answers. So that's why it's great for give me an itinerary for my vacation, and then it's going to give you answers to that. But if you're looking for precision, that's where people run into trouble because of hallucinations, and it just doesn't get there in terms of that critical analysis. So I wouldn't tell you not to play around with it and try how it works for you. But I would also be careful about depending on the answer too much.
Yeah, I think I would say the same thing. Where it's very hard to come up with an end-to-end solution with a tool. Most of these things are not just plug and play, but what they can do is they can facilitate steps in the process. So I don't know how about analyzing this like policy decision making, but you could maybe analyze text along the way. With a lot of the tools that we've talked about today, you can break it down into steps. I've tried to do this for personal projects before. I was really fascinated with could I use so the model that I showed for extracting names, you can use it to tag parts of speech. So what are the objects of sentences? What are the dative and objective sentences, and you can use them to. I was trying to isolate. Could I figure out are promises that people make when they're talking in text? Are they subjective to something else? I will only give you money if we win the election. So you can do this kind of analysis if you dive really deeply into some of these tools, but they won't do it for you, and they very rarely can do it end to end like that.
Mm-hmm. We've got two more questions. One is, can ChatGPT, this is from the Q&A box, can ChatGPT extract data from RSS feeds, or is Hugging Face better? Or is there
So
another one? Sorry, go ahead.
ChatGPT can take the data from an RSS file, but when you do that, you're limited to what it extracts at that exact moment. If you're looking for a more programmatic solution, you're going to have to do a bit more coding, and I think that's what Josh demonstrated with his notebooks, and you might be better off using Hugging Face models for that. But there's no reason, for example, it can you can use an API with a Python library, but for RSS feed, which I assume is real-time data, you really need a programmatic solution for that.
Yeah, so this is something that I actually do a lot. So one of the first things I did when I learned how to code was I was living in Sri Lanka at the time, and I created an email newsletter for myself. And it would basically just hit up a whole bunch of RSS feeds for like the New York Times and Sri Lankan newspapers, and then send me a whole bunch of links. There was no AI involved in that whatsoever. We're just talking about very basic Python tools like requests. These are things built into Python. Most of you actually probably already have Python installed on your laptop, so you could probably already do this without installing anything. But when it comes to analysis of those things, like I think RSS is like a form of HTML, something like that, I believe. And so, yeah, if you were going to try and process it into something else, I presume you could probably use either ChatGPT or models on Hugging Face. It's really what you're trying to do with it.
The last question, I think, because we're coming up for midday and people will start to drop off as we get towards the midday. And it comes back to this overall question of trustworthiness of these tools. I think taking on board what you've both said about none of this replaces critical thinking. But how do we evaluate the performance of custom GPTs? Presumably they're still probabilistic and fallible. Maybe the failures are being beaten down, but how does one compare one with another? And especially for those of us who are beginning our journey, it may not be clear which one's a good one, but how do you evaluate them?
Yeah, so a good rule of thumb is to not trust it. It could, for example, the bot that I used, I gave it to investigative reporters back home, and they use it to find leads. But when it's time to write their stories, they still dig into the document and they still, find the stories themselves. So it just gives them a map to where the stories may be. But at the end of the day, it's them doing the work, the journalism work. What I found though, to answer the question about probability, custom GPTs work better with documents compared to if you just use there are tools like Copilot or Perplexity or even ChatGPT 4 that's not customized. Using a custom GPT app usually provides for better results when you're processing large documents. For example, that Harvard handbook was more than 100 pages, and if you try to use Perplexity or Copilot on it, it doesn't give uh, results as well as you would get if you do custom GPTs. So I think there's a performance boost from doing custom GPTs.
Josh, do you want to add to that?
Again, I wouldn't know about evaluating about models like that, but when we're doing this with some of the examples I showed, basically what we're doing is we have the examples that we're trying to train the model with, but then we reserve a subsection that we call a test data set. And then basically what we're doing when we're training is trying to get as good as we can to identify all the things in our test data set. And the tools that are available when you're doing that will give you scores. They'll give you accuracy scores. They'll give you recall scores. So you get some idea of how well they're going to go. But again, 95% probability of being right does not mean, it's going to work 95 times in a row. So it probably doesn't work like that.
I mean, we did find in the last session AI and text journalism that James Meese led, and this is a moment for me to gently start wrapping up to say everything's on our website. I will circulate to everyone who's registered a link to the site, which we update as we go along with the recordings, the slide decks, the handouts, etc. Strongly encourage folks to join the closed LinkedIn group and just practice. I know I mean, it can seem daunting if we're not used to, perhaps if data journalism and then the coding side of data journalism is something that we've maybe skated around in our lives. Is this the time to go, no, let's go in and have a bit of a swim? But also one of the homework activities doesn't require any coding at all. So let's all have a crack, as we say. But I've posted also a link in the chat to our next session, which is about photography and video multimedia, which will be on April the 9th. Again, a lot of attention on that. I think in recent days, we've seen the discussions in the UK press about Photoshop and the royal family, for example. So how does this happen? that will be one of the things that will be talked about, as well as some of the tools you can use to support production, but also some of the, I'm increasingly hearing the word guardrails to put around tools, and also the editorial policies that those guardrails would then need to inform. So it's a very exciting and interesting time. I want to thank our two wonderful speakers today. So our trainer, dear Josh Nicholas from Guardian Australia, thank you so very, very much for putting all of the work into that wonderful resource, which we'll share. Thank you. And also Jaemark Tordecilla, very best of luck with your fellowship at Harvard University. Enjoy every moment over there in Boston. And thank you both.